So today we're going to talk about a second special right triangle, the 30, 60, 90. Now there's something even more special about this special right triangle than from yesterday. Yesterday, with the isosceles right triangle, you could still solve this problem using the Pythagorean theorem. Regardless what side of the triangle you were given. If you were given a leg, you then know the length of the other leg, and you could then use the Pythagorean theorem to find the hypotenuse. If you were given the hypotenuse, you at least knew the other two legs were the same length. Therefore, they were both x. And again, you could plug into the Pythagorean theorem and solve for that. Today, we can't do that. Today, we are now solving for lengths in right triangles, or in a special type of right triangle, where you cannot solve it using the Pythagorean theorem. Now, the final product works in the Pythagorean theorem, of course, because it's a right triangle. But if you take a look at a 30, 60, 90 triangle, if I only know one side, these three sides are going to be three different lengths. So if I only know one of them, I can't use the Pythagorean theorem. Okay, because I cannot solve one equation that has two different unknowns. All right? So yesterday you could at least fall back on the Pythagorean theorem if you had to. Today you can't. Today you have to embrace the special right triangle. Okay? Well, what they give us in the book, what they give us here from the book is really the shortcut. Okay? It's really the shortcut. So they're talking about the short leg, long leg, and the hypotenuse. Please keep in mind on right triangles, we always know where the hypotenuse is, right? It's opposite the 90-degree angle. The hypotenuse is always opposite the 90-degree angle. The legs are then the other two sides, the sides that form the right angle. So they say one's a short leg and one's a long leg. Why? Again, conversation we had back, I don't know, a month ago maybe now. I told you guys that opposite the 90-degree angle was the hypotenuse and that we knew it was the longest side because 90 was the biggest angle in the triangle, right? Well, that then meant that opposite the smallest angle would be the shortest side. So 30 degrees is the smallest angle in this triangle. The side opposite that then has to be the shortest side in the triangle. With me on that? Okay. So then we know where the short leg is. The short leg is the key to the entire problem when dealing with 30, 60, 90s. If you know the short leg, you take the short leg times 2, it gives you the hypotenuse. Again, if you know the short leg, you take the short leg times the square root of 3, it gives you the long leg. So, same concept as yesterday as far as multiplying by something, but there's now two different things you need to remember. A shortcut way to remember this, just like yesterday I told you 1 square root of 2, today I'm going to tell you it's 1 square root of 3, 2. 1 square root of 3, 2. That is what I want you to remember because every 30, 60, 90 triangle will be similar to a 30, 60, 90 triangle with side lengths of 1 square root of 3 and 2. Now, I'm going to be 100% honest with you guys. When I memorized this, I memorized it as 1, 2 square root of 3. It rolls off the tongue better. Why? Because we count 1, 2, 3.
Yeah.
Okay. The issue with memorizing it that way is you have to also remember that the square root of 3 is smaller than 2. 2 is the hypotenuse. 2 is the biggest number in that set. Okay, and of course an easy way to remember that is that 2 is equal to the square root of 4. So of course the square root of 3 is smaller than that. Okay, you got to remember that. 2 is the hypotenuse. All right, so let's give it a shot. Let's take a look at this first example. This first example here, we are solving for D and F. Please notice it is impossible to solve this problem using the Pythagorean theorem. We don't have enough information, right? But what we can do is, looking at that triangle I have up above, 1 square root of 3, 2, we can set up our proportions just like we did yesterday. 1 square root of 3 and 2. And then below that, I can go ahead and plug in what I know. Now, 1 is the short leg. The short leg is located opposite the 30-degree angle. So there's my 30-degree angle. Opposite that is D. Okay? And then, I can... Another way to do it is just find your short leg and then find your hypotenuse, because they're both easy to find. So the hypotenuse is, of course, opposite the 90-degree angle, so that's F. So I'm just setting it up, and then we know that 5 must go under the square root, right? And yes, you could have said short leg is D, and then said, okay, under the square root of 3, that's the long leg, that's opposite the 60 degrees. You could walk through it that way, okay? But the hypotenuse is easy to identify, and the short leg should be easy to identify. Write those two down. The third side has to go in the middle. Okay? So we have our proportion. Now we want to go through and solve by grabbing 2 of the fractions. Of course, one of the fractions has to be what you know. We know this one, so we have to use it. And we cross multiply like we've always done. So we have D times the square root of 3 equals 5. Well, I got to solve for D, so I'm going to have to divide by the square root of 3. And remember, that means we have to rationalize. So I multiply top and bottom by the square root of 3. So D then equals 5 square root of 3 over 3. That is in simplest radical form. Okay, that is in simplest radical form. Well, we're not done. We got to solve for F. Okay, so solving for F, we then grab the other 2 fractions. And again, we have to cross multiply. So we get F times the square root of 3 equals 10. Again, we have to rationalize. Or I'm sorry, divide by 3. Then we're going to rationalize. So we have F equals... All right, well, to rationalize this, multiply by the square root of 3 over the square root of 3, giving us 10 square root of 3 over 3. There's the answer to F. Now, a couple of things. The shortcut says that I need to know my short leg. If I know my short leg, I can solve for everything else. Right now, they give me the long leg. Okay, so right now they're giving me the long leg. I want to go and find the short leg by going back, from the long leg back. So how do I go back? If I multiply to get there, to go back, I have to divide. So if I take 5 divided by the square root of 3, that'll give me D. And hey, that's exactly what we did when we solved that proportion. We took 5 divided by the square root of 3. Okay. Well, now that I know D is 5 square root of 3 over 3, the shortcut says, well, take that short leg times 2 to give us the hypotenuse. And again, that's exactly what we have. Now, in the work, I don't actually have 5 square root of 3 over 3 times 2 shown here. When did I multiply by 2? Right at the beginning, when I took 5 times 2. Okay? But if I did, just for the sake of giggles here, if I did say 5 square root of 3 over 3 times 2, how do I multiply a fraction times a whole number? Right, I treat the whole number like a fraction, correct? Multiply straight across the top. Gives me 10 square root of 3. Multiply straight across the bottom. Gives me 3. And that, of course, is what we got when we did the fraction, or did the proportions. Okay? All right, last question on this, or last statement on this. Do you think every problem is going to be this ugly as far as the answers? The answer is no, absolutely not. So We need to know how to work with square roots. We need to know how to put stuff in simplest radical form, but not every problem will be that ugly. Okay? So I'd like you guys to flip to the back side of your notes. There's blank pages there. There's blank room. All right, so look at the back of your notes. We're not going to work that jewelry problem. Okay? So all that blank space down below, I'm going to add some extra problems for us to practice. All right? So, what I want you guys to do is to solve this guy. And let's say this is 5. Please solve for x and y. Ready, set, go. So if we work this problem using the shortcut, I know the short leg. This 30 degree right there, that's only there to show us that we have a 30, 60, 90 triangle. It's the only reason that's there. So I know the short leg. To get the short leg, or from the short leg to the hypotenuse, I multiply by 2. So y equals 10. If I want to go from the short leg to the long leg, I multiply by the square root of 3. So x is 5 square root of 3. That's it. Done. Now, what if you didn't remember the shortcut? How would you have done it? Well, hopefully you remember 1 square root of 3, 2. Or 1, 2 square root of 3. However you want to remember it, but remember that 2 is the hypotenuse, right? And so then you set up your proportions. 1 square root of 3, 2. We know the short leg, x is the long leg, y is the hypotenuse, and then we simply solve our proportion, cross multiplying here. X equals 5 square root of 3. Oops, can't do that proportion. We want to set up the outside two fractions, cross multiplying, y equals 10. So either way you do it, you get the same answer. All right, so trying another one here. What if I have what if I give you that? Please solve for x and y. Ready, set, go. Okay, so taking a look here again, if we do this with the shortcut, we know to go from the short leg, which is x, to the hypotenuse, you multiply by 2. So to go backwards, I divide by 6. So x...
Divide by 2.
Divide by 2. Thank you. X equals 6. Divide by 2. X equals 6. Well, now that I know the short leg, to go to the long leg, I take the short leg times the square root of 3. So y equals 6 square root of 3. Again, if you didn't know that, what do? You set up your proportion. And we have x and y and 12. Before I would ever solve this, I always want to reduce my fractions. And so now if I cross multiply using these two, I get y equals 6 square root of 3. If I cross multiply using those two, I get x equals 6. It's the same answer. It depends on what do you need to understand for the setup. Okay? Oh, you wish it was assignment time. We have one more example. So what if I give you, let's do, I'll be mean for a moment. There we go. There we go. Work it the way you've worked it. Don't change what you're doing. Trust the math. You'll do fine. Ready, set, go. All right. So if you're setting up the proportion on this problem, you would say 1 square root of 3, 2. 1 is the short leg, so that's x. 2 is the hypotenuse, so that's y. And the square root of 3 is the long leg, which is, in this case, the square root of 2. Okay? So, if I go ahead and grab a proportion, cross multiply, I get x times the square root of 3 equals the square root of 2. And so I now divide by the square root of 3, which, by the way, is the shortcut. If you're going to go from the long leg back to the short leg, you're going to divide by the square root of 3. Okay, and so that's exactly what we need to do now. Divide by the square root of 3. And so x equals, well, hey, I don't like square roots in the denominator. So I need to rationalize. Multiply by the square root of 3 over the square root of 3. What is the square root of 2 times the square root of 3? Square root of 6. Very good. Over 3, there's our answer for x. Because I took the square root of 3 times the square root of 3, which is the square root of 9, and the square root of 9 is 3. Okay, so let's do y then. So then for y, I'm going to take these two fractions, cross multiply, so I have y times the square root of 3 equals, well now for the shortcut, remember the shortcut is the short leg times 2 gives us the hypotenuse. Well, right here in this part is where we're actually multiplying by 2. So I now have 2 square root of 2. Okay? And then again, I got to divide by the square root of 3. And I have to rationalize. So I'm multiplying by the square root of 3 over the square root of 3. And so on top I get 2 square root of 6 over 3. Which is exactly what we would get had we simply taken the short leg times 2. Okay?